Okay, welcome to today's stream. I'm just going to fix some things in the compiler, extending the compiler to do some more things. So, okay, I'll just remove this test code. So this is where we're at. So the new thing. Okay, so by the way, let me know that you hear me and everything is fine. So if you're like, if the volume is bad or something, let me know. Or if it's unclear on anything, questions, fine. Right. So what we want to do here is to have this kind of thing here, this changing an array of some compile time array. So in this case, the array is actually typed, and this is untyped. And then the next thing, and that's working. Let's just run this. Or I think maybe it's not in here. So this will not work right now. So if I just run this, then it will complain actually here to do breach, yes. And let's see here. So it's in the shelf here. So on show shelf. So that was this one. So let's unshow off those changes. And now we do like this. And barring anything weird, it works. So see here, we are editing this char array, and we add the 8, and then we add the E. And in another case here, we have this 5, 5. We first edited, we do it, well, we assign that actually the value to Z here, and this is to make sure that we don't actually do something like that. We're actually making a copy here, and the semantics are okay. And then we append something to this X array, and then we print it. So you see this, the result here. The last one is the Z, but it's not completely done, because there is one feature that is not in that list, but still has a problem, and that is the case when you have when you are appending to an array that's not a full array. So this is the case here. In this case, if I run this, I think I'll run into an error message from the compiler. No, that worked. Oh, wait. Maybe I fixed that. No, I didn't fix that. Did I? Let's think. Okay, so let me just print this one. Maybe this works still. Okay. Then I need to do like this instead. So maybe it works because it's now expanding it. Oh, maybe it's because it's not an array. So let's append these to that one. It's not breaking now. Yes, now we're getting an error message. So we get an error message, only fully initialized arrays may be concatenated. So W here is not a fully initialized array. So we're going to look at where that happens. So it's like if it's a full array, when we want to concatenate two arrays, then it complains in this case. All right, and what we need to do is basically implement this thing. So we have one solution, which is when it's a const init array full. And I think we need to have these because the scope, there is something put in the scope, so a variable or so. So I need to put inside here. Now, the other case that we possibly could have is when it's just init array. Oh, and then we go to, okay, the fully. Yeah, okay, then we need to, maybe we do the const int 0. So what we have now is, if it's a slice, okay, it's a 0 slice, then it's a 0. Okay, yes. Because that's the only way to know anything about the slices, to, I guess, to know that. Yeah. And then, so if it's 0, then we want to, like, we want to add things to the end of that one. So it's a 0. That means we will have, we are now going to make, in both of these cases, we're now going to make something called an init array thing. So I don't know if I can do this inline or not. This is kind of, I need to, the const init is kind of a little complicated. So in this case, what is the right hand side? So if the right hand, this now it depends on what the right hand side is. So the right hand side is also a type, and it is, like, for in this example, it's an initializer, so const initializer. So it's a full array. So let's think about, what did I do when I had a full array? I don't quite recall. It's probably a 0 and then an array with values. Oh, it's been a while, so that's why everything is kind of hazy. So if you have a full array, you end up splitting that one sometimes. So what happens when I split it? This is the index. So let's see here. Expression contract array. Convert into type, append. Okay, if I just append one, that's easy. So now we're in the hard part. CMA fault index, fault member. I mean, the easiest thing, if you already have a full array, is to basically say that, okay, so it's an array of what was that? It's okay, so we're gonna switch on the other initializer, so it's the other. Oh wait, okay, so we have the first one. It's empty, and we already have the inits, so we need to put something in there. All right, so okay, so if it's an init array full, then we just put it. Oh, this won't work either. This one won't work either when we have a full array, because it is making some assumptions about the code that's not valid. All right, so we might need to rewrite this concat thing. just gonna see if you have any questions so far. So, all right, yeah. So the thing with this, I'll need to explore how it works, because this const init, it solves a problem that's a really kind of tricky problem for Clang and so on, and that is how do you represent a const array in a very compact way. So what it does is that it kind of, every time you insert something into, if you have designated initializers, for example, every time you insert something into that array, it might split it. So for example, let's see if I have that. So const init, and then you have, I recently wrote this one. So here's the meat of the code. So you have, it's okay, so it's not there if it's okay. So we have, for example, all right, let's see here. So maybe in this we need to do this insert, and if we do the insert, then we create a new zero array value and assign it to the location. Right, we are converting this into a value, but the question is, how recursive is that one? So this is in the array value, and it emits that one. Here I'm just looking at how it takes that particular array value and how it handles it. Because like in this case, I'll show you a bit. Okay, so the problem is this. Let's say you start out with something like this. So it's in the beginning it's like this. And now we can describe that one by saying it's just one of these. It's a type of, it's a zero. So then when you pass this to LVM, you can say, okay, the like 5 zeros. So it's a serial initializer basically. Now if I do something like this is 1, okay, we now want to split that into one part, which is 0 times 2, okay, and then I have this 3, right, and then you're gonna have like a 0, and then you have a 1, and then you have a 0. That's how it's supposed to be. And then if I now insert something like that, what it does is it should go to go in here and split this one, so it becomes like 0, 1, 0, and then 1 and 0. So it's kind of recursive, if I recall correctly. But I kind of have to look at how I did this, because it's I made that assumption, right? So we can test that by basically going into the compiler and tracing what it does. But because we have so much stuff here, it's going to be hard finding that particular error. So I'm going to comment out this one, and I'm going to just, maybe I just have a main that mentions this x, so that it gets called maybe x0 or something, int a equals that. And then I'm going to run this without any standard library. And we're going to go into the semantic checking of constants. So let's see here. We have in this file, it's something like const init. Okay, there are so many things in here, so I can't find it easily. It's a designated initializer or something. It's designated. So okay, Sima. Update designator array. Okay, so something like that, right? It will be called eventually. Oh, what? Oh, just have to break and let's just go through and still not work. Okay, so we should be in this particular global, right? If we do this decal, and we should see the decal is this x, right? And it's an defer index expression, doesn't matter. It's an initializer list. It's going to initialize that. It's going to go, and now it's kind of it is going through that in it. So it's it knows it's a runtime const. And let's look at the initializer previous to this, I think. So we rewrite it to 0. So that's what we start with. And then we're going to get like, okay, there's a designator. And the designator here, we'll go back down here, is this element. And from that one, we're going to get a low index and a high index. Right, but we only have one index because we can do ranges. Sorry. Okay, so now it's a 0. In that case, we do init array. We turn this one into an array, right? But we have 0 elements in that array. This is kind of an array with a sparse array. Okay, and then we I don't know, flatten it, and then we go into, we get all the elements in the array, it's empty, and now we have the designated initializer, so we're going to go into here, find there's no initializer, right? So we're going to create a 0 value that we're going to put in that element as the index. So it's kind of a it's just going to say, okay, at that index we have that value. And let's see here what happens next. So, okay, and then we go to the next element. So it's not the last one. So we go in here again. Sorry. Oh, it's just, sorry. I thought it was the ranges. Now it's not done yet, so it goes one more step. Okay, we don't need that. And then I guess we go in here again, and then we find these and kind of put them into an array. Yeah, okay. Now I think I know what to do. Right. So now I see what the program was doing before, what the behavior was before. So, okay. So the way it works, what is like I said, it's just actually, it's kind of simple. It doesn't do this kind of drill down that I showed you, what it does, it starts like this, right? It starts like this kind of thing. And then the first thing it does, this is like a 0. So it starts like with this 0. And then the next step is kind of, okay, let's make it a sparse, kind of a sparse array. And then it takes these, like sets this, it just has like, okay, 3 equals whatever value you have. So what did if I had something like 3 is 5 and 1 is 100, and then what it will do is like just have these. So that's all. And if you have a range like this, it will just do like gladly do 2 is 100. It's not going to be like super smart about that. And the reason for that is that actually you can't do something smart about it in LVM, I think. Okay, so that's how it's going to look. And what happens now if you want to merge two? Let's say I have something like this, 1, 2, 3, right? And you want to add, when you merge that one with something which is a 0, which is kind of a 0, 0, 0, right? This is one case. And then we have the other case where it's the other way around. So it's like the zeros, and it's going to merge with one of these. Okay, and then there's like the zeros are getting merged. And then we have the case where we have something like 1 is 3, and that's going to get merged with zeros. And then we have the and the other way around, of course, right? This case, and then we have this 1, 2, 3. It's getting merged with this style, and then we have this getting merged with this style. And what we can kind of assume here, I think, is that well, there is a problem. Like, if this is huge, then you want to keep the sparse representation. So okay, actually these are simple, right? So this one is simple. We just add zeros. I think that's the reason. That's just add zeros. So keep the kind of this, because it could be like a really long array and you want to add these zeros at the end, and this just use 0. And this is kind of okay. Just change sparse array size, and this is the same. And in this case, I would probably flatten the sparse array, and this should also flatten the sparse array. So you kind of convert that sparse array into a full array, because I think that that's what you want. I mean, you could also convert the normal array to a sparse array. That kind of actually the most optimal solution would be, dependent on the sizes. So if like the sparse array is much larger than the okay, but for now we only need like one strategy, I think. And we need some operations, which is like flatten sparse array, and we need a flatten 0 array. Like these are the two operations that we kind of need for this. Okay, everyone caught that? Okay, let me see what people are writing here. So, are you ever going to the Bootstrap C3? Like, maybe. I think there's a value of just having a working compiler in C, just have it around, even if I would Bootstrap. I would like if I mean, the compiler itself is in C, right? So the difficulty of actually porting this to C3 is like minimal because you can use everything. I mean, I could make a C3 version of this source code because it doesn't. The compiler is not depending on anything that's not in C3 already, right? And I would just need to slap those FN stuffs on top of it, and that's pretty much it. And I could use some simplification. Okay, wait, hang on. I have some gotos, but those are easier to express in the situations when I like whenever I use a goto, it's like yeah, I could. This is something I could write better in C3. But it's not. I mean, I kind of react to people who are talking about self-hosting. It's like this false god, like this ideal I can self-host. And the truth is that you can self-host super easily if you have a super easy, super simple language. So people have been doing like self-hosting in, you know, uh, interpreted languages. Like it's easy. It's not hard. But when you have a language that's not at 1.0, so you have like this moving target, and then you're supposed to maintain two compilers, even if it was that I just converted exactly line by line and it kind of were the same, I would still have to fix things in two places every time I found a bug or I wanted to change the semantics. And I that's just a waste of time, waste of effort, and like just introduces more bugs. So it's like super stupid if I would do that. I know languages that does do this because they kind of, some of them was like, yeah, if I write my compiler in my own language, that means my language is mature and can do anything. But that's not true. I mean, it actually doesn't say anything because writing in compiler is a very specialized piece of. There are a few things that resembles compilers. I guess like search programs, small utility search programs in Unix, on Unix machines, Linux machines. Those are kind of similar because they were kind of batched in a similar way. But if you're talking about what people are usually, writing like web backends and apps or games, it's like a game has nothing in common with a compiler. I mean, it's there are like if your language is geared towards making writing compilers easy, it doesn't say anything about whether it's good for writing games. That's what I mean. You know, it doesn't need to be like bad because it's good for writing compilers. It's just that, and there is no proof. And yeah, you can say, "Oh, I'm dog fooding." I'm using my own programming language, but the feedback you get is so narrow. So it might go in the wrong direction because like you're optimizing for writing a compiler and not for writing other stuff. So your language becomes like having that kind of thing in mind all the time, and I don't want that. I want people to write normal applications with this. You can write like backends, yes, fine. Applications, standalone applications, that kind of thing. I'm not writing C3 for making a language which is to be used to write compilers in. I think that's a very writing compilers is a kind of very narrow use case. So once it's 1.0, maybe one can do that. I mean, I really want people to be able to write the compiler from spec, right? So writing the C3 compiler in C3 from the spec, that would be a very useful thing in itself. But that's because writing it from spec is the useful thing, not to have it in C3. I kind of going out on a rant about this because I think it's so bad an idea because you end up like people are doing it like, oh, now my programming language can finally self-host. Like I can do if statements and use some of libc, and I start self-hosting. I don't understand that. That's like that just adds this enormous problem. That time, that time that you spent doing this self-hosting thing is better spent improving the standard library or removing bugs or something. Don't spend that on writing it in your language because that's supposed to prove something. It doesn't make the language better. Okay, so let's go back to from that rant. I've written about that several times too. So yes, because in the language community, that's like this. Oh, you have to aren't you self-hosting yet? I don't care. I don't care. It's like yes, make the language good. And I mean, I don't have a problem with C either. I mean, that's also the thing. Like, are you so bad at programming in other languages that you have to switch to your own language in order to actually make it work? Then there's a problem there. It's like you already know what the problem is. That's you. It's you. Okay. Sorry. Sorry, everyone. If you have a language and you now felt that I was being mean. Okay. So I have two of them, and before I could just do stuff, but now I have to actually pull those out. So I need the initializer, left initializer. So I need this one, and it's from the element, which will be like the left hand side, right? So, and then we have the right hand side in it. Let's try not to make a typo. Okay, so, but if you are writing a program, just take this, like this is my suggestion. Just don't care about what people say, and just write your compiler, make it work. Spend time making the language good, making the design good. There is so much work to be done. I mean, people are looking like, oh, look at Rust. They are self-hosting, right? And Zig, they are self-hosting. But there are a bunch of languages that aren't self-hosting. Rust has this has this bootstrapping process that you have to do when you're building it. Like this builds in like 10 seconds or something. I don't know. We can build this from scratch and see how long it takes. But it's fast, right? And if you have like this bootstrap, and yeah, it takes a long time to even just get a compiler that can compile your compiler every time you. I mean, it's like you want to make things go slow. Okay. All right, so we have the left-hand side, so we have some special cases. So in the case where we don't have an initializer, which you can have, like the left-hand side might not be an initializer, right? And then you can just... Actually, then you're done, right? You can just pretend that the... Oh, this is kind of problematic, I think. Maybe in this case... So what you want to do is, if you haven't concat expression, yeah, we also want to return the left hand side really. So now you can take, if you don't have any left hand side, then you can just take. Yeah, well, let's see. We want to assert this just to be sure, because it's bad if that would happen at some point in time, and it doesn't actually, isn't actually true. This is my favorite way of catching bugs. It's putting in those asserts to make sure that it actually is stopped somewhere. This is where I get all my almost all my error reports are like, oh, this is assert. It's there and there, because it rarely gets to code gen. Okay, so if the left hand side is not zero, not there. Oh, there's a case. Okay, so if then I can just rewrite it as the. I can just take that initializer. Let's see what the type is. So I don't need to. I need to have this one, right? I can already know that part. And in this case, I rewrite it to const initializer like that, but now I'm almost going to write it to a const initializer, and it's going to be like it needs to be something else. Okay, if the init, then we have some cases, right? So we have, if right hand side is also not that, then we do get an array. We do get a zero array, const 0, and it's going to be like so it's going to write this expression, which is a concat expression, and we're going to get the this type. So here we concat two slices, and what we do get is a 0, but in this case it's actually 0, so I can't do that. So we have to write that const 0, but we have to do a slice. So it has to be like the left hand side type slice. Right, otherwise things, I mean, you can't get, we have a 0 length here. So I guess if we have a 0 length, so let's see here. So okay, we have, if you don't have an index type, yeah, it's an untyped list. Okay, if we have, if the length, now if the length is 0, which we can be, in that case we can already rewrite that in this manner, a slice. So we're going to get a slice. Let's get a slice. Slice type. Get a slice of the given type, which is the index type. So slice plus slice. So, 0 slice plus 0 slice equals slice. Okay, slice. And now we can know, because of that, we can know that this is not true. So assert span right, and we know that the right hand side is something. Okay, because we already handled that case. So that means we can now take the right hand side and we now have another, we have the same side. It's going to be like exactly the same thing, right? Because we have a 0 left hand side, it's going to be 0. Now the left hand side is just going to be, it's just going to be the same thing. but we already have that type, so we write it with the const initializer. We have the concat with new type because we kind of get that erased in a way, and then we're done. Return true. We also have this other case where the right hand side doesn't have an init, and then it's like the other way around. Okay, if it doesn't have an init, then we're done. If the right hand side doesn't have an init, then we do a swap. Do we have a swap? No, I didn't write a swap macro. Okay, so let's do like this then. Okay, so const initializer temp equals. Oh, I'm stupid. So if the right hand side is 0, then the left hand side is then the right hand side is left hand side, and the right hand side is the left hand side is now nil. Okay, so now we are going to assume that we just swap them in case we need them. So now if the left hand side is not, so if now left hand side, if we don't have the left hand side, now in this case we can't do that. Okay, we have to, right? Okay, we know that this one is true. Can't really do that. Okay, so anyway, so now we know that it's true. We have the right hand side. We don't care. We're done. We don't need to do anything other than that. Okay, so we don't need this thing yet. We don't need to create that. Right, so now we know that neither of those are 0 length. That means we eliminated. Actually, we didn't have those, so we have like the nil, basically nil plus anything, and anything plus nil, like this empty kind of thing. This is the one. Okay, so next thing that can happen, and then we don't need to deal with that. So the next thing that can happen is our situation where we have zeros in the second part. So if right hand side so okay, now we're gonna get the inits, right? So we have the init already. If the kind here equals const init 0, then we have the case where we have, well, we can paste that in. So we basically have the right hand side is this. So let's just add zeros, right? So if the right hand side, so okay, so we have one more time. So we have this. If is a constant 0, we have a bunch of cases. So switch on the different cases that we might have. And we have to handle that. So we have the const in 0, right? So now we are still in a 0, so we can write this in a 0 into a 0. So expr rewrite to const 0. No, that's not the one. To const init. So we have a const init 0. Okay, we have to. Maybe it's somewhere here. So this one. Const init new. Okay, so that's the name. Right. Okay. So we have. Now I want to do const init new 0, I think. yeah, constant new 0, and we have this new type, right? So we have the new type, and we're going to rewrite that. So we write this as a const initializer from, and then concat, we have the type, we have this new 0, right? So this handles this kind of 0 to 0 case. So this plus this. I think so, because of the type, yes, the type will make sure that the size is right. Now, this other thing, this would never happen. These unions, those are special for that, and this can never happen either. So, and it cannot be an array value either. So it's one of these. So in the case where we have like this, now we're at this kind of situation here, where we want to have that plus 1, 2, 3. Now, sadly, we need to do like like this. So we will need to create this one, like one of those. All very sad. And then okay, so we know the length. Now we're gonna do like for what's array size I, and it's going to be less than whatever the length is of the first part. So can I get a const length somewhere? How did I get the length? So somewhere up here, sema length from const, right? Shouldn't I kept those lengths? So let's see here. So what do I get? The first part. So I get the length right there. I'm just going to save that for later now. It's getting clear why I just wanted to do that. Everything was a full array. So len left-hand side equals len, right? Okay. And then we go in here. There is something. Okay, sema length from right. So here we go, and basically we can do array size. Right hand side. What do you call it? Len left hand side. Okay, len right hand side is this, and then we can add to that. Right. Okay. In the case of an untyped. Okay, right hand. It's good to have static typing because in some languages that would be like fine. Okay, and then you would hunt that bug down. Okay, anyway, so untyped expressions, we're gonna make that, and I'm gonna add something. There's something here as well, right? It wants to. When it does? Okay, the untyped list, right? So we wouldn't have to handle that as well. Oh, that sucks. Okay, but that's the way it is. So now I know what the left-hand side is. So that was just the length, right? So for every one of those, I'm just going to introduce, add a 0. So vec add, and because those are just expressions now. Oh no, are they though? Those are const init values. So const init new 0, that's what we want. And the type of the element, which is the index type, yes. Okay, so I add that to these inits. And then we go through for each of those initializers again, but on the right-hand side, we are going to do the same thing. but we didn't we do that here, right? For each, like something like this. This is the one, right? I can just copy paste this, right? And then the right is the right hand side in it, right? So, oh wait, full. Otherwise it's bad. Okay. Right. So in this case, it's just people are talking in that way. So, okay, okay, so that was when it was full. So now we're done. So we can just rewrite this again. We are going to have a full array. So we're gonna have init new array full, and we know the type, and we know what the inits are in there. So now we created this thing, and we're done. All right, so far so good. Now we have the init array like that, and this was okay. So we're done with this case, right? So this one is fine. Now let's look at the second one. So we had sorry about that. So this one is wait, left hand side, yes. So this one is done, and this one was done too, right? I think we did that one. Let me just jump back though. There's .0, yeah. And then we have this thing. So just change the sparse array. No, we have to offset it, yes, as well. So now we know what the length is, right? So all we need to do for the init array is to actually offset things. So we're going to go through all of the constant initializers in that particular thing. So we have like right hand side, we're going to have init array. There we go, and it has an elements. So we go through them. So we get an element here, and the element assert that the element is a type of. Actually, I kind of don't like that I'm still doing this because I think that I would already want to test this. But okay, let's maybe do this. Maybe I can do this and it's going to be fine. So let's assert, not that assert, this assert, that the kind is equal to, I can actually assert span there. So the element is equal to, what's it called? So it's const init array value. Yes. So this element then, which is an array value, where is it? So like that. It has an array index, and we're just going to offset that by the left-hand side length. That's it. Right, hang on, I'm just going to type this up, so. Right. And this should work. This is kind of magic. Okay, but that should be okay. And then those are not reachable anyway. So actually, I'm kind of done with that particular case. So we have the 0 on one side, and then we just make the others a to do, and to do, and just do like this. Okay. And let's see here. Okay, there's no name span in. Okay, it didn't have span. I thought it had a span, but okay, guess not. Okay, let's do that on the right hand side because that's going to be the one that has that element. Okay, so okay, another inits. What am I doing? It's going to be like just grab that one, the right hand side init. Yes. Oh, we got an error, but that's fine. Oh, it's missing the main forwarding function. That makes sense. Okay, so there is. This is kind of annoying, but that's the way it is when you have the no standard library. Okay, it's not seeing that one, of course. But what we want to do now is what we're going to do. Like we have a few test cases. So we're going to start with like x is what we do have now. So we have x is a bunch of zeros, but it has a size. So it's like this maybe. And then the other one is like it has a... Oh, I want to use the standard library. Sorry, I want to be able to print this. So, okay. And then we have the other one, which is also empty. And then we're going to look at that. Just print those. This result of those. Which should be fine. That should have size 8, by the way. So let's just run with this. So we get 1, 2, 3, 4, 5, 6, 7, 8. Let's just make sure that it's actually running the code that I think is running. So I was saying like this is the one that it should be, hitting. So if I hit if there's a to do here, and I don't hit that one, yeah, we did that one. Okay, so that's fine. Now let's hit this one. So I will just put the to do here. And then we can do like, we have another one, which is, hang on, it's going to be a full run one, right? So let me do a short z, which is 1.2. And then we're going to print, again, we're going to take the 0 first, right? Because that was the one we were testing, right? So something like this. And now we're going to strike that to do. Hopefully. Yes, we did. And now let's see that that actually worked. If you hear sounds, there's like the cat. One of the cats wants some attention. Yeah, I'm looking at you. Okay, so we got that, the one that as we expected, and then we have the final test, which is when you have a designated initializer. So now I can make it big again. So we have this W, and let's say we have like, so we have like 3 is 1, and 0 is 99. And then we want to again print this. So yes, we can print this one just to so it's clear how it looks like, right? So we can print this one first, and then we print x, and then adding to that one. We're going to make sure that it is indeed hitting this one. I think there's no way it could work otherwise, but oh yes, it hits that one. I'll look at the chats in a second, in case you have some questions. It looks like it lost something, right? So let's see here. So the 0 is going to be 99. That looks fine. But what about the 3 here? What about the 3? So it did, like the first one you see, like here is looking good, but then where is the there's the 1 there. Where is the 1? So let's see what happens there. So something bad happens. So it's an in this, right? And you go to the first element, and it's like, okay, that element is what? Element init array. So element. I'm kind of surprised that this doesn't work. It seemed correct. Okay, so here's the value. It has a wait 0. Index 0. Okay, I have to look at this. It's an int value. Okay, constant value. And the init value is down here, and it has a type, and the type is int, yes. And then we can drill down into this. Let's see here. So it's an integer, right? Yes, but what integer is that? It's 99. Yeah, so this 0 comes first, right? Well, what? Where is the other one? So now, here's the second one. Right, and afterwards the index of that one is what? Is 6. And then type is going to be what? It's going to be 8. So I don't understand. I don't understand what is broken. It is broken, but why? Do I need to duplicate that one, perhaps? Let's put in more of those, right? You know, we can put in all of them. Okay, meanwhile, let me look at what people are saying. Okay, so it's a fun exercise. I arrived in the rant. Welcome to the rant. Okay, so the first two are there, but the other ones aren't. So, like, what happens if I switch the order here? Does that matter? No, it doesn't matter. Okay. Does it just... Wait. Maybe the type is... Oh, yes, I know. Okay, so the reason why that doesn't work is that I didn't update the type of this thing. So the right-hand side now has a type, which is now has to be the new type. Otherwise, it doesn't work. Bang. That's why. The type is in two places. It's in the expression and the const itself. It needs to be there, but that means there are two places where things could go wrong. Okay, so we kind of verify that these are all. This one is also this one is also working, right? So we have verified those simple cases. All right, so then we have the next ones. So, okay, we are done if we have any of these, right? So we're already here, and we can't reach this thing, so make it unreachable. So it's unreachable now, okay. Then we have the case, so now it's not a 0 in it, right? So now left-hand side could be anything. So let's see what... Oh, damn. Actually, this should be in a switch. And now we're getting a super fat switch, like the fattest switch you ever seen. So, but it's going to be better. So let's put the bad ones at top. So the ones that will never happen. So the union, there is no union here. We don't allow that one, so that's unreachable. We have the const where it's int-array value, it's not there either, and we only have these full things. So okay, so then we have the 0, which basically we then do a switch over everything, which is fine. And then we can put that in here, right? What the indentation is just painful though. Pure pain. Okay, but I have to live with that. Okay, so the next case is that when it's a const init array, right? And then there is like, okay, we have to switch again. So we switch on if the type on the other side, right? So we have the kind, and do we know anything about it being 0? So okay, it can't be 0, 0, right? So we have the case where that is these are not possible. Value, those are unreachable. The case constant. Okay, so the value as well. Sorry. Int value. Right. So since those are not there, these are not available, then the next thing that can happen is that there's a 0, right? So we have an array now. We find zeros. What we do now, we just copy and just do this in reverse that we did with these zeros. Same thing, but in reverse. So we already have that const initializer. Let me write that the right way. And these zeros. And this is, I mean, it's a pain because there are so many combinations, but it's not that bad. Could be worse. Then we add all those, and then we add the others. Now just the other way around, and that's done. Then we have the case where we have a full array, right? We can do that. That's the simplest case and the one that we wrote everything for. So then we start with, oh, the right-hand side. It's the left-hand side now, right? Why didn't anyone tell me? I didn't actually look at the chat side. You probably told me. Okay, so again, we have now we have both of them. So we're going to go for, you know, this. First we have the right-hand side, we have the left-hand side, and we just concatenate them. This is like the super easy case, and that's the one that was, you know, handled before. So we end up with last case, and again, we are going to have more cases, right? So we have the const init array, right? So now we have a full array on one side, and we have these, you know, this sparse array on the other side. And now I promised that I would expand, you know, that thing. So I guess I have to do that, and it's a little annoying, but I guess when I say annoying, I mean it's going to be wasteful. It's not going to be slow. It's not going to be fast. I mean, it's going to be a bit slow, which I don't like. It's going to allocate memory that I have to throw away. That's not good. Okay, so we have the left-hand side, right? We fully do that one. And then we fill out the remaining things with zeros. So it simply is somewhat similar to this one, but we're not going to have zeros like that. We're going to have values. So you're going to go like const init. Yeah, we can have a 0, by the way. I guess we can have 0. Darn, we can have a 0 there. Okay, yes. Okay, so what's that? So we first we fill it with zeros. And next, we're going to go through this this thing here. So it's going to be the right hand side. We're going to go through all of the arrays. Array, yeah, it's array elements, right? And then we're going to get one of these, you know, we had before, which were these. We're going to have an index, and we're going to have a just this type. So we have the element. Let's see, we name this. The init is an element, and now we know. Now we can say that, okay, we go to these inits, and we get like this element plus the len ls, and that's going to be like the element init array value and the actual element, right? And then we're done. Okay, so what, did I miss anything? So I think that's all, because now it kind of did everything in that case. And then we have, you know, just the default, which is unreachable, I guess. So we can have, let's see, up here we have the constant array, and then we end up with an unreachable. Good. We are missing one case, right? Let's just see. Yes, one case. So let's add that one and put it in a to-do for now. Okay, so it's been an hour. Maybe I'll answer any questions you might have. Okay, so no questions. Very silent. Okay, but we are getting there, right? So next thing that we want to test is this case where we have the left-hand side. Where is our left-hand side? So left-hand side, this one, right? We want to try that. So instead of, like, we tested this, right? But we need to test the other way around. So we want to test, like, does z plus plus plus. Like when I added that operator, it's like it was. We had something else before. I don't remember which one it was. Like adding that operator was like so crazy, but actually I find that like, that's one of the best things that I have in the language, like sideways. Okay, so now I have that one. Okay, and we were expecting this to be like 12000, right? So let's see if it does that. Oh, we should have had it to do, right? Oh, it broke anyway. Boom. All right, boo, boo, boo. Okay, where did that break? So, oh wait, I think I swapped the cases. Right, I did wrong. So it's going to be a full here. All right. Okay, and then it's going to be the array here. Okay, good. Well, it broke. So we have the zeros. We expect it to go here, right? And so we need a to-do, but it's going to be the to-do in the constant 0 there. So yes, it's hitting this code. Whoa, okay, so we got that. Yeah, I want to add something about why I'm doing this. So I don't expect this to be super useful. But it's one of these corners in the code. Like, okay, you have to have, a full array. You can't add with a 0. You can't add with a designated initializer. It's just going to be like people are thinking, oh, I can solve this with this in this method, and suddenly it doesn't work because like it's just constrained. And better that I make these features good and then remove other features that and have the features actually being full-fledged features in the language. This is something I've been thinking about a lot. Hopefully I'd get the chance to kind of maybe have some way of talking about that somewhere. Maybe I can do that myself or at some interview. Okay, let's go. Okay, so that was working. Now we're going to do the simple one, which is like the full and the full, right? And we had one, so we can have like 0 and this one, right? This one plus this one. So okay, we go for z plus z. And this is interesting, by the way, because those are, when things are overlapping, and I can use things. That's something that I might think about. What happens in the case? Actually, it can't happen, right? Okay, that's something to think about. Okay, so anyway, in this symmetrical case, it's to do, right? But I'm going to, we're going to look at that and see does it work. Okay, and yeah, it seems to work. It seems to work, right? Okay, so then we have like the last one, which is this thing, right? So we have it added to do here, and then we're going to see which one do we have. So it's going to be the Z one. I'm going to plus it with the W. Z plus W, and it's going to yield. Oh, sorry, no, that's the wrong one, right? We already did that. Or did we? No, sorry, it's wrong. It's right. It's right. It's right. It's the right thing. It's the right thing to do. All right. Okay, so we got that. We got it after, it looks right. So we're almost done. Now we just have the difficult thing. Okay, so the challenging one, which is like the has the more features. Okay, so it's the constant array. So I'm going to copy and paste my solution here from before. Okay, so the constant array, okay, we have, just because I wanted these cases really. And then we have like, okay, we have the init 0, right? But now it's going to be like 1. This is going to be like this, right? So what we want to do here is, now it's actually much simpler. So instead of doing anything, we don't need anything else. If it's the 0 and we have the, we're going to copy paste this one, sorry. We're going to copy paste the 0 and this solution here. You're going to copy paste that one down here and remake it a bit. So, okay, so here you're going to take that one, but it's the other way around, right? So instead, we don't have to move it anything. It's just going to work. And it's just going to be a left-hand side type, then the left-hand side in it, right? Maybe I need to make copies of these. I'll need to check that I'm not mutating things in a bad way here. Because theoretically I could be doing that. Anyway. Right, so in this case, oh, sorry, I didn't actually test that. So okay, so that one is done, right? So it's plus these zeros. And all I need to do is basically rewrite it within it, but with a different type. And then finally, we have the case with a full array, right? So we have the left-hand side like that. And now, essentially, we want to do the same thing that we did before, right here. And kind of just, we're going to expand it, but we are doing that in the different order, right? So we are going to expand first the left-hand side. Sorry, the left-hand side is going to get expanded. and that means there's no offset here anyway. And then after that, you can just add the right hand side. And then we're done. Okay. What do we have left? So that's the init array full. And then finally, we have the init array with init array, right? So we have something like that. Now, this can be a little tricky. I think we're going to... Okay, so let's do this. We're just going to have, how many elements do we have? So the elements are like the vec size of LHS init array plus the vec size of, because I'm thinking about this copy thing now. Init array elements, right? Okay, so now I can say that these are the elements. Good. Okay, so then I go through like this, all the elements, and all of those I can just copy into inits. Vec add inits and this element. So this is fine. Then I do the same thing with the right hand side, but I need to make an offset for each of those. Each of those elements we need to update. So element init array elements. Oh, I can't use that. Okay, so I can copy maybe. Okay, I probably have to do that on my own. Okay. I can just, I guess, do this. And then take the element init equals element. And then, well, check it first. And then I can take this init init array value index, and I'm going to plus it with the len, and then we're going to add it. So here I'm making a copy, and now I have a const init this is a new array full, but it's going to be a new array, and we're going to have type inits, something like that. I'm concerned about this one and the one before, but yeah, I'll have to deal with that. Okay, so now the last few examples should work as well. So we did everything. We did a flat. Hang on. We did the flat size this full size thing. So this one we did, and we did this one, right? So what remains are these. This one, that one. I didn't add this one, this case, which is also a case. Okay, so first the 0 case. That would be an X, for example, and add this. So what we'd expect would be zeros, and then no, that we already tested that the other way around. Plus X, right? Oh, plus. God damn it. Okay, so we have our array. Let's see here. Is that the one we wanted? Yes, that's the one we wanted, and we get 3 zeros. That's correct. The other case we had. Oh, we can maybe check that we actually hit that part of the code as well. So this is int array, and this was the one we wanted to hit. So, and we did. All right. The next one is this array full, right? This one. Which is the one I'm worried about a bit, I guess. And that one is going to be fine. This one is going to be fine. Okay, so we have again this, and we plus that 1 to Z. And we see that we're hitting this one as well. Okay, add to do was reached, right? We remove the to do, see if it works. Then we're going to try to break this. All right, we got our 1, 2 at the end. And then the final thing here is this one. Oh, okay. I didn't write that one. A lot of different cases at a lot of different piece of code, but fairly straightforward code actually. And we got it twice. That's good. So the one thing I am worried about is that it's not making a copy, and that's when what happens when we go and do things here somewhere. So somewhere we are mutating. Yes, this one, right? So we have this, and we add that one. And the thing I'm worried about here is that the W here would be moved. So essentially, if I have this, right, and I have Z, I have something else. I need to have something A. Okay, I have A, and it has 3 elements. And I'm just going to point at the first one. It's going to say 1, like not the first one, the index 1. And then I'm going to do like something just like var AA is going to be like A plus plus, no, sorry, I need a b too. It's going to be like this, and it's going to be a 0. It's going to take the b, and then I plus that once the a, and then I want to look at the a here. Is that one mutated or not? So still get at position 0, which is kind of surprising, to be honest. Okay, let me go. This is where it happens, right? So we're going into this place, right? And the question is like, when I do this, why is it fine with doing this copying? Shouldn't the right hand side become like come from the like from here, right? It's there. It's an expression, it's a constant. I'm messing around with that. Shouldn't that break? It ought to break. It ought to break. So I really should make a copy. I shouldn't rely on that working. Well, it seems to work, but I shouldn't rely on that. So again, this here. Tricky. Okay, let's look at the dispatch here. So the dispatch is left and right. The left and right here is like already, it's going to be like a, oh yeah, it makes a copy. It makes a copy, so it's all right. I forgot about that. So it's making a copy, otherwise it wouldn't work anyway. So that's why I can do that. That means I don't need to be making a copy later on here. So this one isn't necessary. Yeah, well, yeah, no, it isn't necessary. So it should be fine to just have element here. And do element here. Let's see if that is true. Right? This would affect just the 99 thing. So the 99 one still looks fine. Okay, so then that's done. But there was one more thing. There was one more thing. So there's the case where you have... Sorry, I'm just laughing because there's so much stuff here. So there's a case where you have an untyped list. And okay, so you see here, if it's not a full array, then we just don't do anything, right? So we kind of have the cases like, let me. So it's on one side, it's kind of like an untyped list rest, yes. Then we just add, and if it's not, then we just do bad things, right? We have, let's do that. So not bad things, but we want our untyped list, and it just is maybe as a string, and it's it could just be 1, 2, hello world. So then we have like these cases, right? We already know, like this case, this thing already works, so we can already do like z plus untyped, and untyped plus z. That works. So this case should be fine. No? What? Use an untimed. Oh. Okay, so yes, that's true. I have to make this. How many entries are there? Okay, we maybe not. 98, 91. So it's going to be 4 entries, right? So it's we have got to cost this whole thing, or things will be bad. Okay. Still no. It's only used as a compiled. Okay, wait. Did I put it? Yeah, I have it twice. Right. Damn it. Darn. Right. Okay, now. Right. So we get like 1, 2, 98, 91. That works. But now we want to use that with zeros. So one of our cases is like we have a 0, so we use that with x, right? And this is going to it's going to complain now. Yeah, it's going to be unhappy with us. Oh, not stop more. So it's going to say like, okay, it's an error, blah blah. Error erase. What? Oh, okay. So in this case, let's see here. So it actually fell on something else. So it's a 3. So it should be like 5, right? 5, 5. Maybe this works. Maybe because it's 0 array. Maybe it's just like, okay, yes, go for it. No, it doesn't work because it expected a full array. Okay, so it expected a full array, but it didn't work on the first one. Did that one work correctly though? I want to check that. So yes, it did work correctly. It did emit these 3 zeros and it was working correctly. So what code did that use? Okay, so we have. So skip 0, 0 arrays. Okay, if it's init and in kind is right, I have to go in here. Okay, maybe there's something special, right? Okay, so if the first part, if the left-hand side is a const, right? Okay, it's a const, and then it's an initializer, and something, untyped list. No, it's not an untyped list, but we have. If we don't have anything, if I need to kind of comment out most of these, I think. We just want to see the X1, right? So let's comment out these so that I can see where this whole addition, like this is all append happens. Oh wait, now there's an error. So the untyped, okay. Forgot the untyped. It is needed. I don't care about the indentation now. They can look bad. Okay, so this works. Let's see how it works. So we get in here. Maybe there's something special like before this or something. Yeah, there's something there. So let's see here. So in the concat, like in the binary here. No. Does it enter? Does it enter this? Yes, it does. And I'm going in there. So we kind of, yeah. Let's solve that. We go to initializer. Yes, we flatten it. It's a slicer array. Okay, we break. And then we get the index type. Everything is fine. Array length. Okay, yes, it's an untyped list. Go. And then we go here. The length, If it's not an index type, okay, it is an index type, right? It has a type. Okay, does it now? Okay, I know. What happens here is that it tries now to convert this. Okay, so 0 slice. No, it's just going to go here. Ooh, what is this? Right? Right? And so it's going to go here. Wait. Wait. Did it just cast it? Right? I think the right-hand side was cast. That's why it worked. Okay, so there was a cost, an implicit cost here on the right-hand side. That's why it happened. Okay, so that's why. That makes it a bit harder actually to check these things. Okay, but let's for now. What should we do? But okay, we can just go to this one because then I think the casting doesn't happen because it's like in the concat it will kind of look at the first one. It's kind of it's a bias. It's kind of it's not symmetrical. Okay, so we have this. We're going to jump into where things fail, and we probably know where it's going to fail anyway. And but we can remove these breakpoints that we're going to hit here. Okay, so we're in here, right? And so we go blah 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 blah. Sorry, blah 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 blah. And now we're here, and we are not having an index type, right? So we're going to do this. We're going to increase length by 1 for some reason. I don't know why. And then we'll go here, and if it's an untyped list, yes it is. And then we're going to go and just add things, right? Those are the ones. And then we're done with that. We're going to go here. So and then we're going to, okay, skip 0 arrays from slices. That's good. Okay, but then we're not handling the rest of them. So, and if init, okay, so we know we can do this, right? So we also know, I guess, that is not going to be, you're going to assume it's going to be like an array. Oh, hang on. Did I just make a stupid assumption? Like, okay, we can look at that later. But I think that maybe we're not assuming that everything is an array. Maybe we have that check or not. I'm not sure. So okay, anyway, it's going to be like a union. And for now, I'm going to assume that it's not there, right? We're not going to have the value itself. That's only inside, and we're not going to have the value. Those are unreachable. So then we have the case where it's a full union, and then we just do like this, right? It's super simple. Right, and then we can continue. So that one is done. So, and then there's the const in 0 case, like, and then we're going to go for each, and we have to, and grab the type from somewhere. Okay, can't do this because of the for each is assuming it has some it has a scope. Okay, so in this case, we can, what is the index type? We're going to have an index type of this. So we're going to grab the index. Do we have the index type? The index type of something, something, something. The right-hand side should be having an index type now. So get index type of whatever the right-hand side is. So of this init type flatten init type, right? So let's get the index type, and then we're just going to go for all of these values. For array size I equals 0, I mean minus len, right hand side. Oh, is the right hand side? Can we be sure it's the right hand side? We can't be sure. So okay, so it's a 0, but we can get the length. So we can get like the Zima. Let's just okay. I feel bad about this. Okay, so if it's a 1, it's the right hand side. So the length is going to be like array size length 0 is going to be like if it's isn't an I here? Yeah, I can use that. If it's a 0, you know, we get if 0 is the left hand side, and otherwise it's the right hand side. I don't know, if probably couldn't be. Well, yeah, that can happen. Okay, so right, and that's the length 0 and a j plus, and then we're going to create elements that are 0 of that type. So the untyped expression, and then we're going to get like create exper const 0, rewrite to const 0. I was hoping for a 0 creation. I think there is one. So const 0, init new 0. Yeah, this is going to create. Oh, it's an initializer. That's not what we want. New something 0. 0. Init new 0. In write to 0. Rewrite to const 0. Damn it, I think we have to create a 0. Okay, so we have to make expression 0 in here. Exper new, exper const from whatever this side is that we have. Single exp. Right, we create one with that span. We rewrite it. Rewrite const 0. That's 0 into a index type. Right, and then now we have a 0, which we put it there. And then we're done. So okay, we have one more case, which you remember is the nasty case. It's the case where we have a const init array. I'll put that as a to-do, right? Because right now we can probably get this to work anyway, the zeros, right? Yes, we have the zeros. The trailing zeros are working. Okay, so the next thing is that we want to have this untyped plus, and we're gonna uncomment this. Uncomment everything. So we want to have the, let's see here, untyped plus W, and we want to have the W plus untyped. So I think the best thing I could do is probably to treat this as one of these const init things, the 0 ones. So start by zeroing out everything. This is horrible, but it also might be the only way to do it in a simple and straightforward manner. And then we have our, we do like before, like here's the case where we have these indexes, right? So we pull these out. We do it in a similar manner here. So we do again a for each, and now of course we have the this whatever the init, right? So the init, and for each of those elements, we do think that we have a we're going to have an expression. So we have like the element in that we have in value, and we have an element in there. So so it's going to be a const express const initializer init is an element, right? It's like that. So the question here now is how to proceed. Because now the element of an array might also be an element of something. It is a bit tricky. Maybe we have something that flattens those things. So how should I handle this? Tricky. Because we're assuming that again that this element is not it's one of those. Okay, so we can do like this. So switch element has a an element itself, right? And that's a const initializer. So again, const. So now we can have a bunch of them. So we can have a 0, in which case we don't do anything. It could be a struct, in which case we have to create like constant, like this. Like we have to take whatever element was there. So we have an element already. We have something at that location, which is that's 0 that we put there, right? So it's going to be like okay, where do we start? So the offset is like this, right? So offset vex size untyped express. Okay, so if we get the offset plus the element array value index, right? If we get this one, that's the element. So if it's if it is a struct, then we can rewrite this expr we can rewrite this inner expr as a the type is the in this whatever the index type was, right? So index type, and we use the const initializer that we already have in that inner element, right? And the same thing if it's a union. And if it's an array or array value, right? In all of those cases, we just rewrite it like that. So, and if it's an init value, then in this particular case, we can just overwrite it. So the inner expression equals this inner element. And now it's just a value, which is an expression. Then we can just write it. So in that way. Going to continue here. Continue here. Continue here. And I'm not sure that this is correct. But that should be it. And now we end up with like, okay, in the case where that is true, let's follow that one, and we should have unreachable here. And we get an error. What's the error? So, okay, it was, yeah, so the size here is longer. Okay, so let's see what happened. So we have the untyped, which is 98. We get the first case with the zeros. That's here. Oh, no. First we get the Z one. The first one's here. Yeah, those are these, right? And then we have these with the zeros. So these. And then we have like this 99 thing, adding at the end and adding at the beginning. So that looks like it is working, although we didn't do anything hard. So let's do the hard thing. So let's say it's an array of an array. And now we call this something like that. And we're going to have like 2 is going to be pointing to this one. It's going to point to 5, right? And then we're going to have something untyped. And it's just going to be empty for now. I think that is the easiest way to do this. And then what happens? Oh, untyped 2, right? And then we're going to do like, okay, what happens if we do the untyped plus this one? And it should be like what? I don't know what the type should be. What should the type be? Let me know. Okay, we get an error, and the error is I cannot do the addition untyped list plus int 3 of 3. Okay. Why? Oh, did I do addition? Yeah, that will never work. Right, okay, now I get an error, and it's, okay. Initialize means, okay, so, oh, wait, did I put 0, 7, okay. So it's 5 elements, right? It's 5 elements of, yeah, so 3 of 5, like something like this. This is what I would expect. It could be made to work. Oh wait, okay, sorry, I need this. This should work. Sorry, this should work. Yes, that works. And the reason I know that now it kind of works is that Okay, you can do like this as well. Let me create a structure. ABC, and it just needs one element or something. And now I can do another one, which is ABC3, and just has, for the first element, A, it has the value 11. Okay, and now we can do like, again, this kind of thing. And we have the ABC, ABC, and it's going to jump in here. So it's going to be in right in this part here, right? So we're going in here. Like, I think this is the first time we go there. Okay, so then the second time we go in here again and kind of go through them and find, okay, it's okay, this is, in this case, it happens to be like, what is it? An element type. It's, okay, that's not what inner element. The kind of the inner element is, oh, it's an array. It's still with the array, right? Okay, so I got struct, yes. Then I have to make it printable, I guess. So if it's printable, and then, okay, yeah, I can make it printable. So fn abc 2 format, abc2 format, formatter f printf self. Where's my self? Self a. Okay, now. Oh, dynamic. Let's write dynamic, right? Oh, maybe I should, make it nicer so we see something from that. But we can see that this one is 11, which was what we expected. And what we could do is, like, we can put some bad things into untyped. We can do like untyped 3 is like hello world, right? And then we do like, okay, untyped 3 equals, untyped 3 plus z, and then we just grab the third thing or the fourth thing, and we just try to make that into this, and then we print it. Why? Because the fourth thing screwed up. Oh no, maybe it's the third one. Yes, in the middle, right? The middle one is going to be 11, right? So we got it. This looks like it works now. This is our test case now, too, because I can put this into a test and then make sure that the output always works like this. So let's put that in concat something. Concat, concat append, yes. I call this like concat append extended and edit. So we got all sorts of stuff in there. We also got, that's that part, but we also wanted the other thing, which was, this one. So maybe I'll put that as a function somewhere. It's going to be like printed anyway. So it will be in there. In the code. Okay, so I call this module test. I need a header. Let's do the macOS x86. Now we're done. Hooray. Expect test ll. And now let's run the tests. I'm going to look up what tasks this was, but now we have 2 new and shiny features in the compiler actually. So I'm switching. You can't see this, but I'm in Safari now trying to look at these features. Type min of the string type. Okay, so there are some interesting problems here. That someone there's wait, there is a lot of them. Oh, what? No. Okay, that's fine. Sorry, I was scaring myself here. Okay, so let's see. We have the first one, which would be compile time arrays, which is 1806. Oh, we didn't try that. Well, we can release notes. And then the other one was, I don't know. I don't think it had a task. Allow to work on all types of arrays. And we see we have another error here. I think that's from a test that was testing that some arrays weren't allowed. Concat, this is the one we just did. So the way you do a test case, this is basically a regression test. This is not me reading the code, unless there is very simple code that I already usually. Okay, so basically no, I'm not reading this code, but it works as a regression test. Oh God, it's big. Oh God, it's huge. Okay, here we go. That was really a lot of code. Let's try to trim it down a bit, but I doubt that this is going to be small. It's because of all those prints. Bad thing about the print statement is that it's passed by any, and the any thing requires, on the LVM side, it looks bad. It doesn't look particularly bad once you go to the ASM for it, but it looks really bad in the LVMEIR. You gotta get like, let's assign some location for it, and then you often pass that location. Shit, it's not good. Okay, that was one, but the other one then we had three. Three. Maybe something else broke that. Oh, vector const, it's breaking. Let's see what we broke here. now we have all our tests in place, so I'm not going to, I can just use this now. Paste the test in here. Okay, and I want to keep that, so I need a main. Maybe I can just use this main. But something happens, right? And maybe I need to call it. No, I shouldn't need to call it unless it's breaking somewhere else. Okay, so let's see what happens here. Okay, I need to call it. X, and I'm just going to give something like empty stuff. Okay, so something is wrong. We are getting a 0 and an 8. So they are not the same type anymore. What could possibly have made that happen? We don't even have... We don't do anything with that. We didn't... We only... we didn't touch that code. It's like, yes, there is some here, but that's the CT concat. And the CT concat is its own thing. Oh, we have the whole thing, this part. What the heck? Did I keep this? Oh, okay. Anyway. I would have seen this when I did the check-in, but yeah. Okay, so but this just makes it more mysterious. Like, okay, wait, there's something here. So resolve script subscript index. Okay, so maybe something here. So I am semi-length from expression. So maybe something here, but like something in my subscripting, but I don't know. Do swizzle anything that makes this break or something? I mean, I'm kind of mystified, to be honest. Kind of has to be something there. So update const initial, maybe it's something here, right? Update the initializer with that array, and maybe I do something stupid here, right? That could be it. That could definitely be. So I have to look at that. It's maybe it's some size or something goes wrong. Okay, so right. I mean, the front end is happy, but it's just the back end isn't. So we get like, okay, it's a 0 initializer with a 0, right? We do an AND with, like, looking at this, they're not the same type, because one side is one like 7, and the other one says 0 with, I don't know, like, so okay, I guess I could kind of simplify this and see where things go wrong. So can I perhaps just do like this? and see if that works, like if that breaks. That also breaks, right? And okay, so it's the first part where everything is 0. This is like the, I have to look at that output thing. Why is it a 0, 1? You know, I think maybe I should return char 8. That should be fine. So just do like this part. Right? Still break, but now it's breaking here. So okay, so now it expected something else, right? Yeah, it expected. Okay, my parenthesis. And now we're breaking because we are at that left-hand side. So left-hand side, now we can actually go into the left-hand side because we are exactly where it breaks. So we have the expression, which is a binary expression. We go into the binary expression. We have the left-hand side somewhere. So left-hand side code is okay. Left-hand side is not loaded. We do go into the binary expression. Oh darn, they are encoded. But it seems like, you know, it's the same problem here. I can probably just do this and it will still be a problem. Yeah, because the designated initializer here, it just gives the wrong type. And let's see, designated. That's the way, that's the stuff that I was working on. So we go into here, right? We can go into this part. Sima update const initializer at. Okay. There. So this one is calling the same function. Oh, no, sorry, that's the one, right? So let's see. It's going to write. It's going to do this, right? It's going to walk through those indices, right? And it's going to update the type, the size, no, the size, right? So let's see what happens. So we go in here, right? And we have this 0 to 7, right? So, oh, maybe this is not it. Maybe this is something else. Yeah, that's something else. So you're going to get a lot of these wrong things now because a lot of things are going in here. Okay, that's bad. Let's go into this, like just turn off everything, return 0, and I'm gonna run this without the standard library. I wanted to check this in today, but I think like I'll kill you all, or you're gonna like die from boredom if I do this. So okay, so we go in here. Let me see what happens. So we're gonna update that one at the index, right? So the index is whatever it is, so we're not like we're going in here, create a 0 value, and continue, right? So this is not the last one. So we go to the next one, and so on. Well, what happens when we're at the last index? Clearly it's something else. This should be the last element now, but it's not. Oh, wait. Is that right? Is that right? Let's see what the const int is now. So the thing that we're updating all the time is this. We have the inner value, which is a constant 0, and it's a UB is a char, right? Yeah. And we go to the next step here. So now we're outside of that. And what do we think that the type is here? The type is that, yes. And we're now done. And let's see what we have in here. So we have the const init. Oh, sorry, we have the, yes, they have the const in it. So look at that one. So the const initializer is init array. It has the right vector. If we look at the const initializer of the array itself, it has elements. Each of those elements have a type. And that type looks fine. So what is happening to this? Why is this not that type in the end? So we can actually look at why things happen the way they do. Doing this, following along with this debugging must be a bit boring here. But let's see. Okay, so let's see if we can fix this quickly. This seems very subtle, but it's just a small diff. So it's weird. Okay, so let LLVM emit const initializer. There we go. All right, we should get to this part, right? So we are getting here eventually. Yeah, after going here, but at some point in time we go here, right? We have the const in it. It's our int array. The type is 8, right? Everything is fine. Okay, let's get the element type. What? And we go to the elements, right? And the first, it's it's index 7, right? And we're gonna add that part. Sorry, what? 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 Like all of those were supposed to be like -1, but it just added 1. Okay. Okay, so that's how it broke. Okay. So update const initializer with designator array. So it looks like this. And so you go there, do all that. And this not the last path element. How do you know it's the last path element, by the way? Okay, so you are updating, sending this over and over again. And in the last path, you just rewrite the ISO. Oh, so you just go to the next element. Okay, so it's actually recursive here. But it makes very little sense that this is breaking everything. It's like maybe it's not initializing and putting things in something that I am not returning it or something. What are the array elements here? Like it should be at. Oh wait. Right. I think I know. Okay, so these are the array elements, and we add stuff to it. Can't do that. Can't do that. It's a bad idea. Because this means that if we add anything to the array elements, which we do, then those changes won't happen. So bad rep is what we want. Actually, it's kind of pain to, maybe I should do that at the end. Let's do it like this. Okay, so we have okay, so the problem was that we have this an array of const initializers. I will mutate that one. The problem is that this will, using this kind of arrays, will not guarantee that the mutation or the mutation of that these vectors will actually propagate. So while this is here, yes, but it doesn't guarantee that that one is actually doing something. So we have to go array elements, because we use the array elements otherwise in here. we like we I think we do. Okay, maybe I'm wrong. I mean, this looks, yeah, well, we do. Right. Now this should work. Yes. Okay, so that was the bug. Actually, it's just a bug because of this. I don't get that every time. But like the array elements are already there, so why do I do that? And there is actually no need to pull out those or pass them. It was just because of how it looked like before. That was a convenient way to do it, to cache it, basically. But now there's no need for it. So you can just get this from the const init, right? So whatever that was, sorry. Const init, init array elements, right? And now it's updating that, and we don't need this part. We don't need that part. And now it should work still. Thank God we had those integration tests, though, like these unit tests and the regression tests. Otherwise, I just would have smoked that. That would be have been really hard to fix and find. Oh God, that was scary. Okay, so there was been some questions. So, right. So plus 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 and pipe as a replacement for concat, add, and or. That's true. So the thing is, like, why do we have that? It's because well, we have like the add, and or in the first place. It's sometimes you want to write code where you don't evaluate like the right hand side if the left hand side is already true or false. So you don't want to type check it. At compile time, you sometimes, is this defined, this x defined, and this thing is also this type. That's something you can write, like very much think that you want to write. But if you use just use and for that, it's going to be then suddenly, like, for everything you have, you're not going to evaluate the right hand side if the left hand side is turned to be true, and that's going to be like really shocking once you have like, okay, let's change this boolean to from false to true. Like if the compiler can find out that is true or false, and it doesn't evaluate the other part of that if expression or something, it's just gonna be like super complicated. I know it's just gonna confuse you, and you just think that something is running that it isn't running, and so on. If that something compiles that doesn't compile, and I know Zig does this. I think this is a really bad idea. So the thing is that this and this bar pipe, yeah, pipe. It is triple pipe and triple and. They are always evaluated at compile time. So that means that the left hand side and right hand side must be constants for and it also says that the right hand side might not be evaluated if the left hand side it already makes the total the result known. So in the case of triple pipe, if the left hand side is true, then it doesn't look at the right hand side, and for triple and, if the left hand side is false, it doesn't look at the right hand side. So that's it. Okay, so another question, okay. you're only sharing one window. Yeah. And we don't know what you're seeing. I hope you're seeing this thing that you what's that? That was quite some time ago. So I right biggest problem right now is now how to do documentation for external libraries. Yes, yes, I can understand that. I really I wanted to have the some docgen in place earlier. Like people have been doing like this half docgen, but not quite there. I don't know. Like I don't know if Zig has that. I don't know what Zig does for the end now. Zig has some really weird semantics because it doesn't even some if a function isn't called, it isn't checked. So you can write code in that that looks like, oh, can Zig do this, but it's not actually not even touched. Okay, so we have some problems still, right? If this is an error, that so this was just the concat slice array. So concat slice array. These are the error messages. So this is just the okay. Let's see it. So 12. You got an error on 12 for an index out of bounds. Yeah, because you do for each. All right, so you will. So this will not work, and we can actually probably jetson this. No, let's keep it for the other errors. So let's run this and see what the errors are in the first place. So so it has a main. Then I should add this main to it. So okay, boom. So you get an error here because at one point in time you get an index 12 that is out of bounds. So index 12. And you actually also get an error later on where this end index is out of bounds. So it's just this thing. It actually works. So okay, where was that? It's in memory or goldfish. Okay. I thought I got it from here, but I didn't. So I didn't get from vector consts. So can I get like the latest thing? That's not it. Here it is. Okay, so we got on this line we got only full. No, that's not only fully initialized. No, we got end index out of bounds on that row here. And then on this row, we got an error, which was range. Right, I'm just going to paste part of the error message. So now I can just run that. Let me go back to your questions. Okay. So okay, the documentation. Yes, it's terse. It's horribly so. The only way to kind of get into the code, the standard library, is to read the standard library code, basically. I would recommend this. Okay, if you are somewhat comfortable with reading the code, the C3 code, I would just pull up the standard, like the libraries here, right? Standard library here, and then I would just like look at the names of the here's right. We have the IO stuff, the libc, the math, right? So basically, go by name here. for what you want. Okay, so some of these things are not checked in clearly, but basically looking at these in some way, kind of try to look them until they are properly, properly documented and so on. Would it help people if I add more documentation to the actual source files? I mean, in the end, it will be, it will be pulled into whatever. Oh, wait. And then it's so. Didn't I shake? Did I change my the wrong thing here? Now let's see. Yeah, classic stuff. So changing, like, pulling it into your editor and then just editing that, putting that into your test file. Sorry, then editing that. Okay. But anyway, just look here. That's what I would do. Like very, try to find here. And would it be helpful if I had documentation here to the source code? Would people read it? Because I could certainly do that. It would be better for documentation, certainly, but yeah. I have to manage my time somewhat. And this is great if some people have been using these a lot. So if they could, document some of that, if they already use it, it would help a lot of people. I'll have to shift place because it's running out of battery on Mac. And but I think we're done. I'll wrap this up and I want to keep the stream up and running for the last boring stuff. Maybe I'll even, delay it until tomorrow and do it when I'm fresh and awake. Okay, so sorry. I'm making the Python tester work in parallel. Just having fun with it. Yeah. The testing harness, the Python thing should really be in C3, but I just haven't gotten around to it. When I did it the first place, like, okay, now I need to implement all those like sub-process stuff from the OS, and so then I got stuck with that, and then I never went back and did other things. So yeah, sometimes that happens. But right now, I just want to make sure that there are some big things that, like, this was actually a big thing. It's I mean, it didn't take that long, but it's still like a major change in how that works, and it needs some cleanup too. Obviously, I can probably make that code a whole lot terser, but right now I just want it to work cleanly, and just have it there so people can start experimenting with these features. And now I'm finding if there are any corners that are left. Probably there are. I want to clean up more stuff so that it's and rewrite some things, not big things, but just make it overall easier to read the source code so that you can see the bugs. Yeah, I guess that's it. So if are there any other questions, so feel free to ask. Yeah, otherwise, good evening and have a good night. And I'll just put on some sad music to wind down. or let's see, have Master Magic.